Hello, everyone. Welcome to another episode of Cuda Education. Today, what I want to do is talk about a thing called the depth pyramid. Okay, and let us just run our baseline application and look at what is going on here. So we have our scene as we normally do, and we have our scene. Okay, but there is a concept called the depth pyramid. Okay, so basically at its farthest point, it's like one tile, and then as you get progressively closer to the camera, so you're decreasing distance from the camera, you start getting bigger and bigger tiles. Okay, and that's why this thing is called depth pyramid, right? So again, as you go farther out, you just have like one tile, and then the tiles get bigger and bigger as so you might have one tile and then a 2 by 2 set of tiles, and then a 4 by 4 and an 8 by 8 and 16. But as you get bigger and bigger in terms of your region, you get closer and closer to the camera. Okay, so that is why it's called a depth pyramid, because you have one smaller region here, and as you get closer, the region gets bigger and bigger until you get to you know right in front of the camera. Okay, um the reason for this depth pyramid, it's not depth, it's depth. The reason for this depth pyramid is basically for the GPU, for the processing, to figure out, does this object, is this object supposed to be in the scene or not? In other words, is this object hidden or is it not hidden? Okay, so for example, for this pixel right here, this region right here, um, maybe before this lantern was here. So let's just move all the way forward. Um, so before this lantern was here, we might have a small tile here. Then closer and closer, we get a bigger tile, a bigger tile, a bigger tile. But then eventually, as the pyramid progresses towards the camera, we get a tile that picks up this light bulb, this light post right here. Okay, we pick up this light post, and then as you get bigger and bigger further, now there's no objects going all the way up to where the camera is. Okay, so the thing is that at some point in the pyramid, we're gonna pick up that this light post is here. Okay, and what happens is that there is a function that basically, as part of the depth pyramid, it basically tries to figure out, okay, you know, of all the pyramids that we, I mean, of the entirety of the pyramid that we have, of all the tiles that we're making, what is the closest thing to it, and what is the farthest thing away from it, right? And then based on that, it basically decides, okay, clearly this light post is here, so we're gonna render this light post here, and we're gonna, let's say, we're gonna block out, at this portion of the building, we're gonna block out the wall of the building, right? Because this light post is, of course, in front of our scene. I mean, in front of our camera, and from the angle of the camera, and from what we're seeing, we see that this light post is here. And that's pretty much the purpose of the depth pyramid. Okay, that's pretty much the purpose of the depth pyramid. Calculates a slice of a depth pyramid from a higher resolution slice. Handles downsampling from odd size depth textures. All right, I'm not even going to get into that, but just understand it talks about downsampling. So I think farther away it's high resolution, but as you enlarge the tiles and see a more bigger region of that region, you have lower resolution. this is very similar to like Google Maps. Okay, guys. So Google Maps, you zoom into a location, you're gonna see the street name, you're gonna see the building, you're gonna see the parking lot by the building, you're gonna see, you know, all the little whatever that's in that particular region, right? But then as you zoom out in Google Maps, now you're seeing the entire all the other streets. You're seeing, the entirety of the city. You might see the county, you might see, this the state, the world, whatever, as you zoom out. Okay, it's a similar concept. But as part of this depth pyramid conversation, we have these functions called, we max these. We have a max function that basically finds, the maximum point in the pyramid where you basically, have an object that is, an object in that scene, right? So, when you say max, I believe you say farthest point, right? So remember, we have our pyramid. It's small at the farthest point, and then it gets progressively larger, like a triangle, right? Of course, like a pyramid, as you get closer and closer to the camera, right? So this max function, with the way how the application is set up, we have this max function to sort of say, okay, let us conservatively look at all objects from the farthest point out, okay? Um, that is the best way I can explain it. The way how the algorithm is set up and the assumptions that are made in terms of distance and all that, we have this farthest point thing, and therefore we use max. Now you could flip it where you would the pyramid would be, the farthest point out is minimum and the closer thing is maximum. But that's not for this application. And there's like, there's all kinds of math and implications about how you go about doing that. I mean, and you can be correct in doing it that way, but I'm just saying, for this application, for this implementation, for how they do it with this, you need to get to do it correctly, to do the depth pyramid correctly. You need to use the max function. Now the thing is that I don't know why they called it minval here in sort of the name for the result of the function. But we don't forget about this. We care about what's actually used in the function, right? So we have max. The max is used in the function, right? And max generally means farthest out. Now, because you have the farthest out, you are generally more conservative in sort of your estimation. So what do I mean by that? I basically mean that, you basically include everything, and then you're conservative because you're looking at the farthest point out. Okay, so you're not, and because of that, you sort of include everything, and then remove as necessary, right? So you start at the farthest point out, and you remove things as necessary, but you do register like the from the farthest point out. Okay. um when so we have that as our, when we have max. Okay. But we could mess around with this calculation, and we'll see a different behavior. So let us change. So we have max for all of this, guys. So let me anchor you guys. We are in renderer. We're in the shader folder. We are in AAPL depth pyramid, right? A metal file, right? That's where we are. So this is where we are, and we are in the depth pyramid function. Okay. Right. Kernel generating depth pyramid data calculates a slice of the depth pyramid from a higher resolution slice, like from the smallest region, like one tile or so, And then handles down sampling from odd size depth textures. I don't know necessarily what that means, but the down sampling means as you get farther and farther out, as you read a higher, a bigger region and chunk of the thing, it's a lower resolution. And you do that because of processing and resources and things and that. You don't want this depth pyramid to be too burdensome. So you do a lower resolution, but you're checking to see if there are objects as you zoom out, and then registering what's going on. Okay, so what we're going to do now is we're going to change. So we have max values for here, and then we also have edge values, the function max values for the edge x and edge y. Okay, but anyway, what we want to do for this episode is just is change things to min. So we're going to change all of the functions to min, and we're going to see what happens. So now we're changing everything to min, and we're going to see what happens, right? So min now means that we're just looking to like the closer part of the pyramid. So we're looking to what's the closest thing to the pyramid. And as you can see here, there's somewhat of every time I move the camera, there's somewhat of like a level of confusion going on, right? And you see it's very uncertain. It's not doing, nothing seems stable. Just a slight movement of the camera changes everything, right? And I'm just moving the camera. I'm just rotating the camera. I'm not even like moving forward or backward. Now, let's say I keep it one place. Let's say I just move forward. See, even when you move forward and backward, you start to get different, flickering behavior. What I wanted to do was kind of look at our friend over here that we've been playing around with. We want to look at the awning. So you can see even with the awning, right? We could see even with the awning that, we get to see through the awning, right? Which is like, very problematic. But again, it has something to do with this whole depth pyramid thing. Let us go all the way up and just look at our scene. Okay, so you can see that there's a lot of flickering, a lot of stuff is going on, and it has to do with the fact that we changed everything to min. Okay, we changed everything to min on our depth pyramid. Let me make sure I put everything back to the way it was, right? And then when we rerun our application, we get back stability. So basically, we now, I guess, are looking at the full spectrum of the depth pyramid, and we're then making a decision. So, we're not just looking at the base of the pyramid, we're looking at the whole thing. That's the best way I understand it. But let me get wiser minds to chime in on the conversation. So again, guys, if you haven't had Claude or Codex set up on your system, you definitely by now should have it set up. You need to make sure that you have the latest macOS operating system. You need to make sure that you have Apple Intelligence enabled on your system, and you need to have a paid subscription to either OpenAI or Anthropic for the cloud system. I have the OpenAI system, which is Codex here, and this is Codex that I'm using. So let us look at what wiser minds have said about it, aka my best friend AI. Okay. So tell me about the max function for the depth pyramid and why it flickers when the functions are changed to min. You're asking about the depth pyramid reduction logic in APL depth pyramid.metal and why switching from max to min causes flicker. I'm going to inspect that shader and the places that so I can tie the behavior, right? So I'm checking one more place that the choice. Okay. In this project, the depth pyramid is a MIP chain of the scene depth. So like MIP map. So this thing called a MIP map. So you see that like the different slices that we have and the information that comes from all of the slices, that's kind of like the MIP map right? So you could zoom in or zoom out of the MIP map, which is basically these kind of like slices. Anyway, in this project, depth pyramid is a MIP chain of the scene depth where each lower resolution textile summarizes a larger screen area. So remember, as I said, as you zoom out from that small point and get closer to the camera, you're biting a larger area, right? So in this project, the depth pyramid is a MIP chain of the scene depth where each lower resolution textile summarizes a larger screen region. The kernel in blah 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 is a max, is using max, even though the variable is named minval, right? So again, I don't know why they call it minval, whatever. That is deliberate. This renderer uses normal depth conventions. Depth is cleared to 1. We saw that where the clear depth value was 1. Opaque depth testing is less. We also saw that where we said, listen, we are prioritizing the things that are closer to the camera. So the depth testing is less. We saw that in a previous episode. So smaller depth equals closer, larger depth equals farther away. Right. So the smallest depth is closest to the camera, and large depth is farther away, right? Again, it's a convention for how the application was set up. With that convention, taking the max over a block stores the farthest depth seen in that region. So we're looking, so we take the entirety of the pyramid and we say, what is the maximum? We're looking at the farthest depth seen in that region. That matters because the occlusion test later is, and when you say occlusion, basically you're talking about like discarding stuff, right? That's what I've come to mean when you say occlusion, right? So compare value, blah, blah, blah. So we have, right, so the compare value, the max depth, compare value, max depth, cull. Okay, so the pyramid is being used as a conservative occlusion structure. If an object's nearest visible depth is still behind the farthest depth stored for that coarse region, then it is safe to say the object is hidden. Let's read that again. If an object's nearest visible depth is still behind the farthest depth stored for that coarse region, then it is safe to say the object is hidden. All right? So again, the whole purpose of this is to figure out, is an object hidden or is it being seen, right? So if an object's nearest visible depth is still behind the farthest depth stored for that coarse region, then it is safe to say that the object is hidden. So I guess what it's saying is that, like, if you're at the base of the pyramid where it's very wide and stuff, and maybe there's an object at that base part where it's wide, right? And because there's an object, you store a value at that point because the MIP map, the slices says, hey, there's something here at that point. And you have another object that's further down in the pyramid, like in the cone of the pyramid, right, in the farther region in the cone of the pyramid, and the value for that object, the closest part of that object, is still lower than what's at the base where you do have something. Then you could basically make the assumption that farther object in the cone of the object is hidden, and you don't have to worry about processing it, right? If an object's nearest visible depth is still behind the farthest depth stored for that coarse region, right? And you notice how it says coarse, because remember, as you get closer and closer to the camera and you're biting off a bigger and bigger slice, it's lower and lower resolution. So if an object's nearest visible depth is still behind the farthest depth stored for that coarse region, then it is safe to say the object is hidden. Okay? When you change your reduction from max to min, the pyramid starts storing the nearest depth in that region. That makes the culling test over aggressive. Okay? and a single nearby pixel in a large block can make the whole block look occluded. So a single nearby pixel in a large block can make the whole block look occluded, even if most of that block is actually open space. As the camera moves, small changes in projected bounds, MIP level, and which four samples are read cause the objects to flip between culled and visible, which shows up as flicker popping, right? So my occlusion, occlusion means hidden. It might not be discard. It means hidden, right? So as the camera moves, small changes in projected bones, MIP level, and which four samples are read cause objects to flip between culled and visible, which shows up as flickering popping. So short version. Max here, conservative stable occlusion culling. So basically with Max you are more certain because you sort of are reading the whole pyramid and you're looking at the farthest point and then working your way backward. With Min here, aggressive incorrect occlusion culling for this compare logic. The flicker is false. The flicker is false occlusion, not a rendering race. Okay? If you want, you can explain. Max is the depth in the depth pyramid means for each 2x2 block of depth values, keep the largest depth value and write that into the next MIP level. In this render, that is a correct choice because depth is test is less, depth is cleared at 1, smaller depth equal closer, larger depth equals farther. So Max stores the farthest depth seen in that screen region. Why that matters? The culling shader asks essentially, is the object entirely behind what was already drawn in this area? To answer that conservatively, it compares the object against the pyramid's farthest depth for that region. That avoids accidentally culling visible objects. When you switch the reduction to min, the pyramid stores the nearest depth in that region instead. Then one nearby pixel can make the whole region look blocked. As the camera moves slightly, the sampled MIP level and text cells change a little, so objects flip between occluded and not occluded. That flip shows up as a flipper, as a flicker. Okay. What do you mean by occlusion? So let's ask my bestest friend what they mean by occlusion in this case. Right, occlusion means an object is hidden behind other geometry from the camera's point of view. Example, if a wall is in front of a chair, the wall occludes the chair. The chair may still exist in the scene, but it shouldn't be visible because something closer blocks it. In this project, the depth buffer and depth pyramid are used to estimate that hiding. If the renderer can tell an object is fully behind already drawn depth, it can skip drawing that object. That is called occlusion culling. Okay, so right, that's the official word on occlusion. So there you have it, guys. That's all I have for this video, for this episode. That's all I have for this episode. But, obviously I'm going to have to investigate some more. But we do have a better understanding of what is going on when it comes to this thing called the depth pyramid, right? And, we're just moving along, guys. It's 2026. First quarter is basically already over. Yeah, we got 3 more quarters to go. We're trying to learn metal as much as possible so that we're in a better place come December going into 2027. So let us keep at it. So you know what to do in terms of my channel, all of that good stuff. Support the channel, tell your friends, start working on this stuff. For you MacBook Neo guys, I'm talking to you. Okay, you MacBook Neo guys, you could run this application on your MacBook Neo. So if you already got a brand new MacBook Neo, you got your early Christmas present in what? In March, okay? Make good use of your Christmas present. Or maybe it's your spring present or your winter present, however you want to call it. But make good use of your new MacBook Neo. Learn Apple Metal. Okay? With me, and you will be well on your way. So anyway, that is the depth pyramid situation. I'm sure it's going to come up later in some other point. At this point, I can't really, discuss all of the intricacies of it, but I do know this max and min thing is very important. All right. Thank you for watching. Have a great day.